Okay, so memorizing all the formulas and all the conditions, that scares a lot of people. Well, the last 2 pages of your note spiral have a list of conditions and formulas, and that's a good place to make flashcards. And it's also it's just a really good place to memorize this thing from. And Mrs. Lamb posted in the Google Classroom for us one that was blanked out so that you could fill it in to practice. So that's a really good practice tool, because the more you write things, and by the way, writing is better than typing. We remember what we write more than what we type. So that is actually a really good thing to practice. Having said that, I'm going to try to help you out with a couple things. First off, our basic formula, our starting point, is z equals x minus mu over sigma. So that's where we start. And I'm going to relate this, and I believe Mrs. Lamb has already done this in her class. I did not. On the formula chart, the standardized statistic, which in this case would be z, is our statistic minus our parameter, x minus my mu, divided by the standard error. So that's where that is. And I don't think you ought, but you actually won't find that on the chart. So you'll have to know which ones you're working with. So, and it's like, well, what if I have a sample size, or they tell me I'm working with an average and they do give me the standard deviation of the population? Well, in that case, because I'm working with an average, I'm just dividing by n. All right. And remember, this is also the standard deviation of the sample means. So if they ask you for the standard deviation of the sample means, this is it. All right. Now, what if they didn't give me the standard deviation of the population and instead they gave me the standard deviation of the sample? Well, if they gave me the standard deviation of the sample, all I'm doing is swapping out this for that. All right, that's all I'm doing. Now let's talk about our conditions for these two. Random. It's either going to be random sample or random assignment. And you need to pay attention. If it's random sample, say random sample. If it's an experiment, it's random assignment. If you're not sure, they said treatments are randomly assigned. Well, it's random assignment. If it's a survey, they randomly selected or randomly sampled. So you need to either write the word sample or assignment, and then you need to say that it was given and the problems given, and check that off. The next are the conditions, and I'm going to call them the Goldilocks. And n can't be too big, so it can't be too big. So you're checking for too big, or maybe I should say not too big. And the other one is not too small. This is the n is less than 10%. That's the n is less than 10%. And not too small means, and we have 3 different ways with the t-distribution to do this. They can be nice to us, and they can tell us normal from the beginning, in which case we're good to go. For the z, it's going to have to be normal. 2, n will have to be greater than or equal to 30. This would be for the t. The third one would be check the data with a graph. Now, please be careful with this when you're checking the data with the graph. You draw the graph, it's beautiful, and you say reasonably symmetric, no outliers, and then you can say it's okay to use the normal approximation, or it's okay to assume that it's normally approximated. All right, so let's pause for a second. All right, no questions here. With a paired, it's exactly the same thing, x bar d minus mu d, SD divided by the square root of n. So all you need to do is drop the d in there for the differences, and that's because you were subtracting paired values. And on that one, you're almost guaranteed to have to do a check, and you're only doing it this will only have one graph. All right, this would only have one graph that you have to draw. But basically, you're following the same ones. The next thing, two sample. Well, here's how I want you to try to remember this. And this may help you with combining random variables. Remember, if I have a standard deviation of 3 and another standard deviation of 4, I can't subtract them. I have to square them and then add them together. Okay, so here, for a two sample, we have x bar 1 minus x bar 2. But you go, whoa, well, what about the mean? Well, let's talk about the mean. We technically have two means. So mean 1 minus mean 2. And you're like, but Mr. Spencer, you've never had us write down that part. And you're right, I haven't. And here's why. Our null hypothesis is mu1 equals mu2. Mu1 equals mu2. And if mu1 equals mu2, that means if I subtract them, mu1 minus mu2 equals 0. So this equals 0, so it went away, so I don't need it. So that leaves me with this part. And so then I was like, oh, what was my standard deviation? Well, it was s over the square root of n. But remember, so I have s over the square root of n minus s over the square root of n. Well, we can't ever subtract them. We have to add them. So this becomes added. So then I end up squaring these two things because that's what we had to do. So this becomes s squared over n plus s squared over n. And that's where the denominator came from. So s1 squared over n1 plus s2 squared over n2. So really all I did was take what we had up here and squared it and put it all under a radical, and I had to do it for the x1 and the x2. So that's where this formula came from. I'm not sure if that helped or not, so I'm going to pause. Okay, so we got the conditions. Well, guess what? Random sample, not too big, not too small, and I need to have three ways to check it. Normal, n greater than 30, or check the data with the graph. Now, the thing is, I have to do it for both samples. So I have to do it twice, once for each sample. Also, they actually have that. So this is here's my denominator right there. That's my denominator right there. So, and that's on the formula chart that you will be given. All right. So, and you're like, hey, where do I find the formula chart? Go to my website. It's on that website. With proportions, they're always z. And the hard part about a proportion, quite frankly, is just knowing the denominator part, because the denominator part is different than what we worked with before. Guess what? Here it is. All right, here it is. And you're like, well, what's the difference between the two of these? This one right here is for a confidence interval. This one right here is for a hypothesis test. All right, that's the difference. Two sample is going to follow the same rules as we just had previously over here. This is going to be p hat 1 minus p hat 2. And guess what? This is hypothesis. And this is confidence interval. Hypothesis test and confidence interval. Okay. And the thing is, oh, excuse me, did I swap those? Yes, I did. Ignore that. This is your hypothesis. That's your hypothesis right there. All right, so there's your formulas for your hypothesis right there on your formula chart. The other thing on the formula chart while we're here that is super important to recognize, these formulas are right here. Binomials right here. Geometric is right here. So please spend some time looking over those formula charts. Now we have some weird formulas here, and I know I'm off topic, but I'm still going to do this. If they ask you something really oddball and weird about regression, these tie to regression. Chances of them asking you that almost impossible, but could happen. Okay, so lastly, wanted to talk to you about confidence intervals and regression. First off, all you need to know with regression formula-wise, T equals B over SB, or T equals T star times SB. Oh, excuse me. B hat plus or minus T star SB. This is your hypothesis test. This is your confidence interval. This is going to come from your computer output. This is going to have degrees of freedom of n minus 2, so be careful about this. This is standard error, okay? So this is for your confidence intervals. And also on your formula chart, confidence interval. Statistic plus or minus your critical value times the standard error of your statistic, okay? So if you're working with proportions, this is going to be p hat. If it's two proportions, p hat 1 minus p hat 2. If it's means, it's x bar 1 minus x bar 2. If it's a single mean, it's just x bar. If it's proportions, this will be a z star. If it's anything else, this will be a t star. All right. Standard error. Once again, you can get that. This right here is your standard error. This is your standard error. This is your standard error. This is your standard error. And you can actually find those things on your formula chart if that helps you out. Personally, I like to memorize them, but if that's not your strength, then remember this right here, this little line right here tells you, hey, X bar, this is either going to be X bar, B hat, P hat, or X bar 1 minus X bar 2, P hat 1 minus P hat 2. And this will either be a Z star or T star, and this will be one of those standard errors. Please remember, with regression, they're already divided out.